Okay, sir. A
Just
very good
give me a
evening
sec.
and a warm welcome to IoT Revolution Club and IEEE Chapter's first collaborative event. The topic for today is ML in IoT. It is my privilege to introduce the guest of honor for today's event. We are indeed privileged to have Mr. Atanu Chowdhury, noted entrepreneur and CEO of Capsule Labs. Atanu sir is an IoT evangelist and the founder of Capsule Labs. He was a techno-functional consultant for IoT AI-led digital transformations, providing delivery and solutioning support to Altix's global sales team. Prior to Altix, Atanu sir was a member of technical staff at Infosys, Harvard Sensor Networking Lab, Telcordia Advanced Technology Solutions Labs, and Blue Highway. He has a postgraduate degrees in computer science from IIT Guwahati and Harvard University, and he is a senior member of IEEE and Computer Society of India. The motivation behind these records lives in the passion. This passion started at a young age and continued till today. Thank you all, and I think Atanu sir is going to take over now. Thank you, sir.
Thank you, Guram. Let me set up. All right. Welcome one and all. A very good evening to everybody who's present today. And I know that all of you are, very young, curious minds. I've had an excellent interaction with the team previously, and in continuation of that, we are going to go ahead with this discussion. Right. Today's topic is on machine learning in the Internet of Things, and a couple of ground rules I want to lay down before we get started, right? First of all, please feel free to ask questions. If you are hesitating to ask questions, you can ask your questions in the chat window, right? The more questions, the better, because the kind of questions, it not only helps you, it also helps all your colleagues, all your friends when we discuss those questions together. Right. So that's the ground rule. Please feel free to ask as many questions as you want. Right. Today's discussion, the way I'm going to structure that, we are going to have essentially three broad areas with which we are going to discuss this. And the first thing is, why should you care about IoT, right? Of course, you are the IoT Revolution Club, so an introduction to IoT is not really necessary over here. But even then, we should understand what are the new things that are happening in this area and how to leverage that. We are going to take a little detour and we're going to talk about how the street lamps improved its IQ and became smart, right? And we'll look at how machine learning plays a role in this kind of an IoT implementation. And thirdly, we are going to look at what are the opportunities, what are the career opportunities, particularly in the area of IoT. So that's our focus. All good? Everybody's audible?
Yes.
All right, I'll move on.
Yes, sir.
Thank you. Some of you may have seen this slide before, but for the sake of the general audience, let me begin my story essentially by talking a little bit about how we got here today, how we got into the era of IoT. And if we have to look into that, I think we have to start looking at the late 1980s when essentially the personal computers started to come into the market, and it might look very strange today, but the ability to have a computing environment available to you at your home, at your disposal, for you only to use whenever you felt like it, right, was a big step from the world of mainframe computing, right? So that was a big change when you suddenly had access to computing power at your home, right? By the mid 90s, you started seeing laptops coming into the market. And with laptops, what was happening was, whether you were a field engineer or you were a scientist or you were a salesman on the go, you suddenly had access to your data anywhere you went, right? So business communication, scientific communication, all of these kind of activities started to accelerate simply because you not only had the computing infrastructure, you also had just a battery along with it, right? So you could take your computing infrastructure with you, right? By 2000s, feature phones had become very, very popular, and you could be connected at any point. You could be making decisions, while you were on the move, right? By 2000s, there were almost a billion phones or feature phones that had already been sold, and these phones were not only for voice calls. You were starting to see MMS come onto this. So there's a little bit of WAP and internet connectivity that was becoming available with these phones, right? So in this 20 years, right, the world has suddenly changed because now you had computation, or rather portable computation, and and the capability to kind of have wireless communication, all kind of starting to come together, right? The next major change came, by the mid 2005s, when by the mid 2000s, when you had the social media becoming very, very popular. And with social media, suddenly that boundary of being online or going offline, that started to blur, because you wanted to be always connected. You were always interested in trying to understand, or trying to know what your friends were up to, and they wanted to know what you were up to, and that cycle kind of continued. So by 2005, what was happening was social media was driving internet access, which in turn was closely related to another development, which is essentially the smartphones coming into the market, right? The smartphones allowed you to have almost the whole screen being used as a window to the internet, right? So you were always connected. The world was always connected to you, right? Major development. So in 30 years, suddenly your ability to interact with the world, right, was no longer it was no longer tethered anymore, right? And the mobile phones, these smartphones, were pretty portable. They were already pretty small, right? Driving the vision in terms of thinking about smart dust, thinking about, where else could you bring in all this computational capabilities, computational and communication capabilities together. That really is where the Internet of Things started to really come in its own, right? Before that, you had machine to machine communication, and this was an area which has been explored in terms of industrial communications. You had telemetric solutions, right? But these were pretty elaborate solutions. You did not have the portability that was available with this new generation of computers, of microcontrollers, of wireless communications available at a price point that made deployments of large numbers of devices possible, right? With the development of the mobile phone, suddenly you had a device that had a lot of sensors kind of built into the phone itself, right? And taking advantage of this, uh, were the startup companies that were starting to kind of change the way we interacted, right? There were these the Zomatos of the world, the Swiggies of the world. All of these services started to pop up, the Ubers of the world, right? Where you were no longer satisfied with going through the whole process of ordering from a restaurant, going there, picking up your order, coming back, right? Now you are also becoming very, very data hungry, right? You wanted to know when your order was placed, when your order went into the kitchen. You want to know when somebody is assigned to pick up that order, when the pickup person has arrived at the restaurant, when they have picked up the order, how far they are. You want second by second update, right? And that would not have been possible earlier. It is made possible because the cell phones that they are carrying are embedded with a GPS tracking system, right? It's embedded with a GPS receiver and is able to also communicate that information. So suddenly, our uh, demands from the systems that we have around us, they have been growing pretty exponentially, right? You have to understand that all this while technology has been growing exponentially, right? And technology has been growing exponentially because the computational environment has been following Moore's law. It's been doubling every couple of few months, every 15, 18 months, right? The number of people who are getting assigned to developing new technologies, that itself has been increasing. There are more and more engineering colleges, more and more engineering graduates who are going out and building the technology. And finally, there is also the previous generation of technology that is also available on which we are building. So there are these three reasons because of which there is more and more technologies getting created, because of which we are now able to find solutions much faster. We're able to build solutions much faster. We don't need the capital investment of previous companies. Today, a garage startup has the potential to become a unicorn in a matter of anywhere between 3 to 5 years, right? That's the pace at which technology has come into the picture, and these connected solutions are coming into the picture, right? And no better example than the smart cities today, right? Where they are cashless. There is a very strong a digital India stack that is available in terms of eKYC, in terms of e-payments, in terms of blockchain enabled systems, right? In terms of new data models that are coming around, right? With solutions varying all the way from smart parking solutions, smart EV charging solutions, all of these solutions feeding into what we call largely as the smart city solutions, right? That's where we are. 2020 wasn't too far away. Somehow the last couple of years have kind of blurred in everybody's memory, but we are still in 2021, and smart cities is very much a reality today. All of you have experienced some aspect of it or the other, right? But what is important here is that there is this exponential increase in digital interactions that are happening because of this increased penetration and depth of usage, right? More and more people are starting to use these services, these digital services, these connected services, and they're using it more and more, which in turn brings us to the part of the data, right? Because of this exponential increase in the digital interactions, there is also an exponential increase in the amount of data that is available about these transactions, right? The amount of metadata that is available, the amount of data is allowing us to model certain behaviors better, right? It is allowing us to understand and even predict where traffic snarls, where traffic jams are likely to happen, in the future. Right? It is allowing us to understand where the demands will change over time, right? It is allowing us to kind of predict how things are going to fail, how machinery is going to fail, right? So that is where we see the amount of data driving the machine learning ecosystem, right? Uh, Analytics, AI, all of these things have been available for the last almost 35, 40, 50 years, right? We have been studying them in theory. But the availability of the data and the availability of the computing infrastructure to process this data, that is what is different about the machine learning that is happening today, right? So machine learning, the important part you have to understand is what is valuable about machine learning uh, uh, is the relevance of the models that you can bring out, right? Uh, IoT, I don't have to say too much about it. IoT is something that is pretty much domain agnostic. It is being used in Industry 4.0, enterprise IoTs, consumer electronics, right? You see a lot of, right from Alexa to Siri to all these conversational platforms, right? You see how smart lights are being built for the house, right? So these are all under the consumer electronics umbrella. enterprises, they are using IoT for energy management in buildings, for prediction of the building transport failures to the building transportation system. They are looking at IoT for access control systems. So a lot of businesses are using enterprise IoT for essentially simplifying their processes and making it easier for them to manage operations. Right. Similarly, with Industry 4.0, you are seeing a lot of operational efficiency coming out of this IoT-based solutions. And the thing I wanted to talk about today in greater detail was about essentially these smart cities, right, where there are a lot of services that are being offered, and these services more often than not leverage connected components, connected hardware, and connected systems, right? Somebody have a question? No. Okay. All right. So in my mind, where IoT is IoT is a lot of infrastructure, right? You can see from here. What happens is you have the field devices where you have the different kinds of sensors, whether it is a light sensor or a motion sensor or a temperature sensor, and somehow this data is getting aggregated through these endpoints coming onto field gateways, aggregating further down into what we call our edge gateways, slightly more capable devices, right? And then on through cloud gateways, right? Coming into the application backend, coming into a web server from where it is being viewed through either a mobile interface or administrative portals, or reports are being generated out of it, right? So when you talk about this a complete IoT solution, right, they are essentially a heterogeneous environment. You have different kinds of devices which have different capabilities, right? They are not just different grades of Linux servers, right? They are fundamentally different devices which have different kinds of limitations. Some of them have high computational capabilities, some of them have high network throughput, and some of them have are battery operated, have very limited computational capabilities, right? They are cheap, they burn out pretty quickly, right? So you see this heterogeneous environment, and any solution that you build in this kind of infrastructure has to take this into account, right? You have the sensors, you have these routers, gateways, cloud systems, servers, right? You have to take into account the differential capability with respect to the computation, the sensing, the communication, the storage, and the power requirements of each of these devices, right? Not only is IoT a lot of infrastructure, but because of this infrastructure, there is also a lot of new job opportunities in this IoT ecosystem, right? If I compare this to a traditional IoT system, right, you will find that there are these traditional jobs that are already available with respect to the business analysts, the UI designers for these portals, the mobile app developers, the front-end developers, the back-end developers. These kind of jobs are definitely going to be there. What is new is this new set of jobs that are coming into the market, right? You have the semiconductor OEMs who are building the chipsets for these IoT devices. You have the field engineers who are going and installing these kind of applications onto these devices, onto and commissioning these devices in the field, right? You have the device OEMs who are manufacturing the devices, testing the devices, creating their compliance, right? And looking after their interoperability, right? You have the network engineers, right? You have the cloud DevOps guys, you have the machine learning developers, right? And you have the control room operators especially when it comes to the smart city environments, right? These machine learning developers, the data that they are looking at is essentially data that is coming in on almost near real time from the field devices, right? So that's what they are trained to process and parse. When you are developing these algorithms, right, you have to take into account that there's a lot of this streaming data that you are having to handle, right? The control room operators, as I said, is very important for, especially for the smart city environment, right? Especially where you have a lot of these smart city platforms that are giving in data to a central control room where everything can be kind of monitored. Uh, and if I can put it right, there are quite a few smart city applications out there, right? It's not limited, right? If I take an example, all the way from street lighting, right, to parking, right, finding out where a possible parking spot is, being able to make a parking reservation before you leave your house, right? Traffic control, being able to predict where the traffic jams are going to be and dynamically switching these lights, right? Making sure that ambulances, we saw this entire pandemic unfold before us, and the availability of healthcare information, these ambulance information was very, very critical in kind of saving a lot of lives, right? Being able to deploy your the city's uh, infrastructure to help as many people as possible was very, very important, right? Waste collection, another major area where we see a lot of where we see a lot of smart cities adopting their IoT based solutions for waste collections, knowing where waste is likely to be gathered, where should the pickups happen from, right, so that the trucks don't return back empty, right? You have companies which are already billion-dollar companies in the waste collection waste collection space, already having been created, right? Public transport, that is something that we are very used to today now, right? We are, in the world of Uber and Ola. Public transport is actually not doing badly. A number of cities, Bangalore, Hyderabad, right? A lot of cities are actually implementing GPS enabled buses so that people can now go to the bus stops as the buses are about to appear, right, as the buses are about to arrive there. So because, when somebody is waiting for a bus at the bus stop, without just plain waiting, it is just dead time. It doesn't help anybody, right? So that's why the implementation of IoT in public transport is a boon for all the parties involved, the citizens as well as the transport companies, right? Utilities is another area, water metering, electricity metering, right? So all these metering kind of activities, that is where we see a lot of IoT based applications, right? In the registries, like tax registries, motor vehicles, right? The registries are also trying to start use IoT with respect to the kind of data that it is collecting. More so, the registries are using a lot of blockchain based systems, so that it creates immutable records, right? In today's talk, I'm going to be focusing a little bit more on street lighting. That's why I did not bring it up, right? Because I want to take you through this journey about this street lighting use case, and looking at street lighting as, hey, we all know about street lighting. How can it really get smart, right? What happens if we use IoT in street lighting, and how does it improve its intelligence, right? So that's essentially the next section of my talk, right? Any questions so far? I don't hear any questions, so I'll kind of continue. Yeah, somebody has raised a hand. Yeah.
Sir, he has texted the answer.
Somebody asked the question, what is ML SaaS? And ML SaaS is essentially, I'm sorry? Yeah, ML SaaS is a machine learning software as a service, right? Where the algorithm is where a machine learning model has been developed by a particular company or a particular organization, and for a, with a given data, you are allowed to query that particular model, right? I'll give you an example. Amazon has it has a system called Lex, right, which is a natural language processing algorithm, right? It can discover intent from words that are given to it, right? And Lex is something that powers Alexa in the background, and you can use Lex for creating your own chatbots, right? So you subscribe to Lex, and Lex is essentially a machine learning algorithm as a service. You subscribe to Lex, and you can pass it a string, and it will map it to an intent and give you back a response corresponding to that particular intent, right? You pay for, and they have various tiers. So maybe 50,000 queries a month is free in the free tier, and then you have to pay for additional volume of queries, right? So this is the freemium model of using a machine learning service, right? Hope that answers your question. So moving on, let me talk about street lights, because this is a very interesting example, right? Again, I always try to start from a very historical perspective, and generally you had these older generation of halogen lights, which were these were vapor lamps, and they were omnipresent in our cities not too long ago, right? Now, if you look at these kind of lamps or this kind of street lights, they are manually lit, so somebody goes in and switches on each of these lights individually. But they are not very, they're not really very efficient, right? If I look at the luminescence isoline of these street lights, what happens is you'll find that, there's a lot of light. These are two street lights, and you see the luminescence score of about 1.4 over here, about 1.7 over here, and it fades away pretty quickly, which leads to this banded light that you get. You see some light around the street lights, and then you get dark patches in between. But this is not a particularly smart system, right? You have these lights, and somebody goes on and switches them on every evening. If they forget, well, the light stays dark, right? There's nothing smart going on. So in my IQ meter, this is a very dumb light. But if I switch to LED lights, right, LED street lights, they are incredibly efficient. They are very, very power efficient. If you look at for the given amount of power, you find that there is very little degradation of the light as it moves, right? So with these LED lights, you see the light actually spread out more evenly. So that's definitely a big advantage. Now, there are a couple of additional advantages with these LED lights. First of all, there is, apart from the electrical components, the LED is an electronic component. It's, at the end of the day, it's a light emitting diode, right? And if it's a diode, it works on DC voltage. So there needs to be a converter or some power conversion circuitry inside the housing itself, which is converting the AC light that it is getting into DC, right? There is, so there's DC voltage that is available over here, right? And this light does not radiate a lot of its electrical consumption in the form of heat, right? It converts most of the electricity into light, which is why they are very, very efficient. So, but in the bigger scheme of things, right, this street light, somebody still has to go and switch it on, which means that it is, in terms of its operations, it is still exactly like what it was before, right? There isn't a lot of advantage over there. So in my IQ meter, nothing really changes. Somebody is going and still switching it on, right? Some of you could argue that, well, what if this light was powered by solar, right? That is definitely a possibility. It would make for some efficient implementation. But given that in a city where the utility lines are laid out very, very densely, the cost of a solar panel, an inverter, and a battery is still going to be very high at a per pole rate, right? Which is why we still use electricity to regular AC lines to power them. As I mentioned, what the advantage with these LED lights is that they are now bringing this conditioning circuitry and digital electronics inside the luminaire. That's the change that has happened. Now, if I wanted to make this system smarter, what can I do? Well, the first thing I can do is, if I build an IT system where I essentially take the GPS location of every street light and plot it on a map, right? What can I do? Well, I can build an IT application that's going to show me the location of every light. With this, and just need to build a field force application for geotagging. I go in front of each of these lights and I just geotag this is where the light is. And this data gets captured in this IT application. Now, this application is not connected to the street light given, right? But what I can do is with this map view, I can start creating these IT workflows, right? Somebody can call me and say, look, a particular light in my locality in front of my house number so-and-so is not working. And I can take that as a complaint, right? The utility department can take that as a complaint and create a workflow so that somebody gets assigned to replacing that particular light, right? Other IT workflows in terms of, say, ordering for new lights or running a scheduling algorithm, right? All of a maintenance algorithm, right? All of these things can be done using this IT application. Right? So there is some amount of smartness that we have been able to create, but the applications are still very, very disjoint. Right? Which is why I've called this, on my IQ meter, it gets probably 1 out of 10. Right? Because the information is disconnected. If I could connect information from the street light itself into my IT application, if I could connect this operational technology with this IT technology, with this information technology, well, then I have a IoT application. And if I am making an IoT application, I need to understand the technology stack for building these full stack IoT development, right? With an IoT application, what is happening is you have the devices, it's away from here. From a model perspective, you may use for your data stores, essentially, you may be using a Postgres or you may be using a MySQL as your databases, and you could be building the controllers on PHP, on Apache, on Python, on Node, on Express, any of these technologies, right? With the front end being made in terms of either a plain HTML, CSS, or Bootstrap, or React, or Angular, or Vue. Many of you would have heard these terminologies, I'm sure. Right? And you can build this full stack IT applications over a LAMP stack. Very few applications on the LAMP stack, but nowadays it's mostly a mean stack or a merge stack, right? Where you're using either a Mongo, Express, Angular, Node, or React and Node, or Vue and Node, right? If you're building very complex applications, you can definitely go with Ruby over here. That was a little detour, but coming back to our street light, our smart street light. Now, what do I need to do in order to make this slightly smarter? Well, what if I put a wireless transmitter on that? Right? And what my transmitter is supposed to do is it's supposed to give me this information about, if I send it some information, rather, it can receive that information and operate a relay over here, or a variable port, right? Which will essentially, I can send a on, off, or dim command. Right? If I can do that, then automatically I can build the next class of applications. What is the next class of applications? Well, I can do offline remote operations, which means I can use my application to turn on a particular light remotely. I can switch it on, I can switch it off, I can change the luminescence, right? Or I can define a schedule, right? And this schedule tells me that a light is supposed to start on from, it is supposed to be, I can't see, from sunset to sunrise, it's going to be at 100%, 100%. Then later in the night, when nobody's really using it, it can go down to 70%, 50%, 30%, 25%. There's more and more sunrise that is coming in. And then it stays off throughout the rest of the day, right? So I can define a schedule for either a single light or for a group of street lights. Now, clearly, you will all agree with me that this is a a smarter system than what we had previously, right? We can also make this algorithm weather based, right? Not only a predefined schedule, we can make the schedule based on the weather inputs we get for the day, right? So where we are using a weather SaaS service, something like a Wonderground or an AccuWeather, like one of these services which will provide you the cloud cover for a particular pin code, and I can use that to dynamically alter the schedule or to make changes to the luminosity of these particular lights, right? So clearly a new set of applications are now possible. What else can I do? Well, given that I now know when I have switched on a particular device or when I have switched off a particular device, right, I can now make some energy consumption estimates. I know exactly, what was the, from the vendor of this particular light. I know its energy consumption, right, and I know when it was switched on and when it was switched off. So I can estimate what is the energy consumption or what is the expected energy consumption for this particular street light, right? Let's move on a little bit along this premise, right? Let's move to what if I could monitor the usage, right? So instead of estimating, what if I could actually now measure when the light was on and when the light was off, or if I could measure the current drawn by the light. If I can do that, then I don't have to estimate the energy. I can now get a value for that. Uh, so the control applications we had discussed earlier, and along with that, I'm now adding this usage capability. So if I do that, I now get this very interesting graph of what was the energy consumption throughout the day, right? What happens now is, with this bidirectional communication capability, where I'm not only sending it commands, but I'm also getting some information from the light, I'm able to now monitor the actual usage data of energy, and that will allow me to model the energy consumption of specific vendors, right? So if a vendor A's lights consume less energy in the field or not, I now have real-time data to measure the quality of products from vendor A versus the quality of lights from vendor B, right? It allows me to make this scorecards, right? It's a very powerful tool because now I have this vendor scorecard. I can now, as a city, give my orders to those vendors whose products are better, right? There is clear data that is supporting my decision over there. If a particular street light is consuming more energy than what its estimate is showing to be, what its usage is showing to me, it allows me to understand if there is pilferage of energy going on, if the line is being tapped illegally, right? It allows me to get that kind of information out. So I can not only do vendor product scorecard, I can now detect if there is pilferage happening, right? So these are additional use cases that I'm starting to build up, and these use cases are adding value to my system. They are helping me save money as a city, right? Now, when I talked about these usage monitoring systems, right, there is a degree of sensorification that is going on, right? Now I have this embedded system that is sitting over here, which is collecting this data, right? So if I look at the IoT embedded development piece, and this is where all of you are, much more experts than I am, right? We talked about this deployment infrastructure over here, right? But if you look at it, you have these embedded devices. What they're doing is, at the leaf, they are running these two stacks, right, where you have the serial stack, which is essentially talking to the particular types of sensors, right? This is over either a I2C port or an SPI port, or somehow they're getting the data from the sensor itself, and they're transmitting this data over a low power communication network, usually what we call is an IoT stack, right, which takes into account the power, the compute bandwidth, and the storage constraints. And then there are these field gateways and these edge gateways where this it is running a IoT stack on one end and an internet stack on the other end, which means that this part is low power communications and this part is internet capable communications, whether it is over Wi-Fi, whether it is over an Ethernet network, whether it is over a 4G network, right? So it's running an internet stack on the other side. That's how we get the bidirectional communication between the cloud and the street light, right? Then this leads to sensorification. If I can get data from the sensor over here to my application, right, over an internet connection, then, well, what is limiting me to monitor only the usage? I can start monitoring other kinds of things, right? Say, for example, I start monitoring ambient conditions, right? Ambient conditions, as in, let's say light levels around me. So if I find that a particular street light is in a location where the neighboring houses already have a lot of gate lamps, a lot of other lighting sources, and there is already a lot of light in that area, then this particular street light does not need to glow at full luminescence. Right? So I can have this ambient light based automation, not on the weather forecast, but on the local conditions that are available. Right? I can create this model which says that if there is a lot of light in the surrounding, then glow at say 60%, 40%, or even lower. Right? I can look at other things. I can look at this, the sound levels that are there, right? I can look at the toxicity levels that are there, right? And I can start creating this urban pollution models because I have high resolution data available from each of these street lights, which are placed probably 65 meters apart, right? 30 meters apart mostly, right? About 100 feet apart. So this urban pollution model helps determine which regions in the city should command a premium, what are the methods or what are the policies that the city council should take into consideration when they are sanctioning new projects, right? If there is, for example, a lot of sudden noise or the sound level for a particular street lamp is very, very high, right? Then you know that there's something going on over there. You may want to send a law enforcement team over there, right? So now it is what was the street light is now starting to integrate with other departments, with other arms of the city, and they are starting to work together, right? That's the beauty of it. It can look at the temperature and the humidity and look at these heat pockets within the city itself. Often what happens is if you have two glass buildings that are facing each other, then throughout the day, the reflection will keep on bouncing and the heat traps or heat will get trapped in certain parts of the city. Right, so you get to understand them at a very, very close. You get data with very, very granular resolution, something that was not available earlier or something that cannot be done using satellite imagery, right? So you get this temperature data for trapped heat maps, you get air quality monitoring about the city, right? So you get insights about enforcement agencies where there is some trouble that is going on, right? So this interdisciplinary interaction is now being facilitated just because the street light is connected to some sensors. That's the benefit of sensorification. Right? And when we talk about these models, right, that's where you see a lot of these ML SaaS. Somebody put out this question: what is a machine learning software as a service? Right? And I had shown this picture earlier where we had the field devices, where we had the viewing devices, but now, unlike IT-based systems which rely a lot on data stores which have been more relational databases, with machine learning we see a lot of different kinds of databases that have come into the picture, and these databases are geared towards specific applications. Like, of course, you have Postgres, SQL, all of that, but then you see this document DB in terms of Mongo. Right, you see this time series database in terms of Cassandra, right, where there's a lot of questions when you are asking a lot of last 5, last 10 minutes, top 100, these kind of questions, Cassandra is extremely good, right? In a lot of cases, you will find images being sent to you, right? In which case, something like Amazon's S3, which is just a storage bucket, that can become your data store, right? Or Firebase, right? Google Office Firebase, that can become a very interesting database of choice for your application. There's Apache Spark when you're creating multiple streams from the incoming data stream, right? That's where Spark comes into the picture, right? And the programming interfaces for building your models have also changed. Python with its NumPy and SciPy libraries offered a lot of powerful tools to build your own algorithms. Similarly, you have MATLAB, right? MATLAB already comes in with a lot of data transformation algorithms that are part of its regular package itself. If you don't like MATLAB, you can look for its open source version called Octave, right? You can build a lot of these algorithms in C++. It will take you slightly longer, but you can build more efficient algorithms. There's of course R, there is Julia, right? Of course, you can build them in Java. It's got lots of libraries, right? Depending on the performance that you need from your programming framework, right? Or in my advice, right, you should not be building these algorithms if you can use them, right? If you are thinking about building an end-to-end application, then your value add is in building the application, right? Then I always recommend that you leverage the machine learning tools that are already available, and there's quite a few available, right? There are machine learning tools that are, or algorithms that are available from whether it is Amazon's SageMaker, or it is Azure's machine learning platform, or Google Cloud's AutoML platform, or IBM Watson. Each of them are entire suites of machine learning tools in between, right? For example, if you go into Amazon SageMaker, I'll give you an example of that. There are multiple machine learning components that are available, right? For example, there is something called Amazon Comprehend, which is used for natural language processing. I already mentioned Amazon Lex, which is used for building, say, for example, conversational chatbots, right? There is Amazon Forecast, which is used for building time series forecasting models, right? There's something called Amazon Recognition, right, which is for image and video analysis applications, right? There is Amazon Poly, which is used for text-to-speech translation, right? There is, there is AWS Deep Lens, there is Deep Composer for deep learning services, multi-level neural networks, right? So there are a lot of these services that you can explore in order to build the kind of application that you want, right? With this armament of tools at your disposal, building an end-to-end application should not be that difficult. Which is why, if we want to bring in more amount of intelligence into our application, we can look at these predictive maintenance solutions, right? Where we can now look at, we can look at the usage data of a particular vendor's light, look at when does the light start, when do these lights start to give way, and start creating failure prediction about this light. So we will now know when a light is likely to fail, right? When a light has reached maybe 80% of its mean time to failure, right? If we know this information, then what we can do is we can go ahead and create a schedule, to a maintenance schedule, in order for somebody to go and replace these lights before they fail. Or we can take these lights out and put them in locations where their impact would not be that much. So I can balance the cost versus the utility metric, right? That allows me to create these maintenance routes dynamically, right? uh, and I can give a maintenance app to the field force so that they know exactly which lights to replace after the first one. uh, so they are not wasting time going around and checking for failures in places where there aren't any, right? So you can save a lot of cost in terms of your maintenance crew as well, right? What else can we do, right? Well, what if we look at So far we have looked at a sensor being able to do a lot of things, and the sensor giving us this ability to optimize the kind of lights we buy, the amount of maintenance staff that we need for maintaining this important service, right? What happens now if we put a camera on the street light, right? We already have a street light, it's up there, it's almost 15 feet high. What if we put a camera over there? We can do object enumeration, we can start counting things, and we can count objects, we can count people, we can count, not count, we can detect number plates, right? And of course, I just mentioned that Amazon has this wonderful service called recognition, so I can use that to do my counts, right? And suddenly I can now start to measure how many people are walking down a particular street lamp, right? And this kind of gives me a measure of the utility of a particular street light. It allows me to plan for what kind of street light should I put there. If there are more people who are using a particular intersection, or are walking down or walking past a particular street light, then I know that this is important, right? And I may want to change the wattage on that particular light, right? For to do that, I am taking an image, and I am essentially running a few things. I'm doing some image classification, I'm doing some object localization within this, I'm doing some object detection, and I'm doing some instance segmentation, right? What this allows me to do, it also allows me to create this light rotation schedule, right? So in areas where a light is not being utilized, I can actually bring back those lamps which are at 80% or 90% of their mean time to failure, so that they get an extended life over there, while I replace the more used lights with newer ones, right? It will allow me to keep a balance between the new procurements and the utilization factor, right? I can look at traffic segmentation, how many cars or what types of vehicles pass by a particular road, right? That allows me to kind of measure if there is a lot of cycles that are going under a particular street light. I want the beam to be narrow, right? If there is a lot of vehicles and cars that are going by, I usually want the beam to be wider, so that there is visibility further down the road, right? I can look at number plate recognition within the from the street light itself, right? And as a fun thing, I can look at even city theft, right? If I can count that every day in front of this particular street lamp I see a bench, so every day it will return me a count of one for bench, one for bench. Then one day, if it returns me a count of 0 for the bench, I know that the bench has been stolen. Yeah, Anubhav had a question saying that some of these Amazon services must cost to be implemented in a product. So is it better to use this and pay Amazon, or rather make a team for engineers to develop your own system, right? So this brings us into a question of, whenever you're building a solution, you have to think of whether it is a build versus buy versus make solution, right? If it is a service where creating that service or maintaining that service is critical to your business, and you want to maintain the IP for that particular component, then the recommendation is always to to create a team that will build it. But if this is something that is not foundational to your business, then it does not make sense to build the whole solution, right? For somebody who's going to offer a city lighting service, right? For them, the main business is going to come from operating this infrastructure at the least possible cost, right? Therefore, for them, when they're looking at building a solution, they will usually look for using a third-party system which is already coming with its own guarantees of performance, with its own guarantees of reliability, scalability, all of that, right? And then you also have to kind of you pay as you go, right? Instead of paying upfront for a team and maintaining that team even after that application is even after the integration has been successfully completed, right? So it depends from an organization to organization. uh, and that's where you kind of make a decision based on the cost and time to market for that particular requirement. uh, a few people had questions, a few people had raised hands. I cannot see the queue of people who had raised hands, unfortunately. I'll come back to those questions shortly then, right? So this is where we are talking about city infrastructure, city infrastructure threat detection. What else can we do, right? Once I have data about one particular street light, right? The next question comes, can I start to build metadata and look at the information that I get from not one street light, but say a series of street lights? And that's essentially where context awareness comes into the picture. Because by context, I means it is not only it is not only the data for that one street light, but a group of street lights taken together. And this allows me to essentially build applications like, say, follow me lighting, right? Where a pedestrian is walking down one street lamp and the light brightens up to help them go past it, and then the next light has turned on before the pedestrian reaches the end of the reasonable luminosity zone, right? That's how you can have this handover essentially happening from one street lamp to another, right? Then you can have this context aware advertising, right? Where you look at the kind of people who are coming together, right? For example, over here, I can detect that there is a group of two people, a group of four people here, a group of two people here. Whether this is a group of college goers, or this is a group of business associates, or this is a group of friends who have gone out, and maybe I can customize this ad based on who is walking past or what kind of group is going past them, right? So this opens up opportunities for these for these media companies to kind of have a dynamic response system or a dynamic advertising system based on user inputs, right? But notice one thing, if I build this kind of service, then this connectivity pipe that had established, which was earlier sending in only sensor data, it did not require a whole lot of bandwidth. But the moment I was sending video data, I needed slightly more bandwidth. The moment I am sending video data and I am playing back video, I now am starting to use higher bandwidth connectivity for the image and video transfer, right? Which means that these are applications that you will start to see as we get into 5G implementation systems, right? As the bandwidth available for the network increases, you will start to see significantly more complex use cases come into the market, right? You can do push advertising, and this is very interesting because now with push advertising, you are now looking at essentially having a Bluetooth beacon on the street light itself, right? And the Bluetooth beacon is essentially pushing an advertisement as somebody walks past. So these are hyper local ads that can be pushed by this street light infrastructure into a pedestrian's phone, right? So that kind of push advertising is possible. Gives you ads like, say, discounts on the barber shop 10 meters down the road, right? So you are now able to access somebody's you are able to create that instantaneous decision making, right? As somebody is going past. So these are new use cases that are still under development, but you will see them getting implemented sooner than later. What else can we do? Well, what if we integrate speech and voice recognition into the street lamp, into the street light, right? Not unheard of. Why would this be useful? Because in a city, you have people coming in from different places. They may not speak the local language. They may not understand the local the local map, right? So in this case, what we can do is we can use Lex, we can use an Alexa integration directly into a speaker on the street lamp itself, where somebody could come in and ask for these public translation services, right? Somebody comes in and asks a street lamp, when is the next bus available, right? One for dash nas bus, right? So how far is the nearest hospital? You can ask this location aware queries because the street lamp knows its location, and therefore it can answer questions relative to its own location, right? You can ask about when will the next bus be here, right? You don't have to define where here is. So you can ask this question even without knowing where you are, right? The street lamp will answer that question for you, right? Of course, you can, some of those questions can be answered by your cell phones today, but this is a good public service to also provide, right? You can ask this time aware queries. So with speech and voice recognition, you're now seeing a new generation of applications that are now being enabled. Let's take this another level further, right? Let's look at gesture and intent recognition. Now, unlike images where you are processing things one frame at a time, when you talk about gesture, you are processing video, right? And when you're processing video, you are looking for, doing image processing on a set of images, right? Very, very quickly, right? And that allows you to do certain new things, like, like it helps you to make the city safer. It allows you to do weapon recognition, understand the concept of threat, of mob identification in the neighborhood of a street light, and take appropriate proactive action to dispel a bad situation from unfolding. Uh, of course, you now need faster bandwidth, because now you're talking about video streaming. Now, here, uh, one of the things that has been done in the area of IoT is something called edge recognition, and you are looking at some of these edge gateways and video analytics being done at the edge itself. So that is probably something that will help reduce the bandwidth requirement, and you'll see much more expensive devices or much more capable devices being installed to manage all the infrastructure of the street lamp itself. Right. You can have auto alarm modes over there. Finally, when you now look at not only just a series of street lights, but you look at the overall set of street lights across the city, thousands of street lamps across the city, you can now start to do this context aggregations, right? You can now look at crime prediction. You can look at epidemic arrest, because you will now know where people are not wearing masks, right? So where there is a likelihood of a pandemic breakout event likely to occur, where the lighting levels are low, and correspondingly where there is the potential for a crime breakout to happen, right? Somebody asked the question that what if the police has a gun, will it still be recognized as a threat, sir? Well, if the police has a gun, then it will be recognized as a gun, right? It will be recognized as a gun. It will be recognized as a weapon. Now, whether the policeman or somebody with a weapon, you can build a system where when you detect somebody with a gun, there is an auto escalation. The control room gets notified immediately. A picture is sent out, and let them take a human decision with respect to whether that is a threat or not, right? Now, you have to understand that this is a very, very interesting question, because at some point, as the system is becoming more and more intelligent, as it is becoming smarter, it is still missing out a few things. It is still not human intelligent. It is still not able to make to understand complete context. I will come back to this thought process in a little bit, right? But if I look at what is the value provided by the smart street lights, right? then clearly, if I have just the street lamps, just the LED lights, and along with a renewable source of energy, I can reduce defects, I can reduce overproduction, I can reduce the amount of inventory I need. Right? If I build IT systems, we reduce moving these lights from place to place. We can reduce people having to move around, trying to go around doing their inspections. I can reduce the amount of effort it takes to move inventory, people, processes, all of that. It reduces waiting. And if I look at this first level of applications, right, you see a lot of benefits with respect to reduction of people, reduction of goods, right? Reduction of the waiting period, of approval period it takes to make these approvals go through, right? But if I look at this bottom half, if I look at, say, for example, predictive maintenance or object enumeration, context awareness, speech recognition, these are all essentially new services. These are completely new services. So while IoT today is at a stage where it is realizing the values over here in points 2, 3, maybe over here, this is where it is going to start making an even greater impact. And 3 to 5 years down the line, you will see these applications becoming mainstream. Right? Having said that, I'll go back to the question that I had left earlier on, right? Because even though our street lights has become smart and it went on from a scale of 0 to 10, it is still has a long way to go when it has to compare with human level intelligence, when it has to talk about generalized AI, right? So what we are doing, we are still creating models, and based on those models, it is still a rule and event based outcome. There is some amount of complex event processing that is happening. So there is rule engine, and we are able to compute the rules within certain time frames, right? We are able to bring in a temporal aspect, right? We are able to probabilistically search through the solution space, which is what our machine learning algorithms is allowing us to do. But we will still not be able to identify if a weapon is being carried by a uniformed officer and whether that uniformed officer is genuine or fake, right? If somebody is masquerading as a police officer carrying a gun, right? That is something which requires a significant amount of human knowledge building, and machine systems are still not there today, right? So I want to make that very, very clear, right? So we are somewhere in between. We are in between a robotic intelligence and a generalized intelligence, right? We are somewhere in between. That is why we are more intelligent than the halogen lighting systems that we have seen. But having said that, we are not close to human level perceptions, right? I hope that is clear with all of you. Right. Hopefully someday we'll be able to, today we saw that how we are able to now start integrate vision, sound, speech, smell or odor, right? We are able to bring those senses into our smart lighting system. But yeah, we still don't have touch, or maybe we will have touch one day. We still don't have taste, but things are evolving, right? Things are evolving, and newer applications will only come out into the market, right? So with that, is there a question? Anubhav asks if we can give authorities and an NFC card, like a badge, which they can intercept if he's real or not. Yes, that's a viable solution. That's definitely a viable solution to. Nowadays we have a body cam, right? So police, most of them are using a body cam. So if the body cam sees a particular street light, and the street light sees a body cam, they can cross check those two feeds, seeing if those are coming to the same feed. Who knows, that might be another way of validating whether that police officer is a genuine police officer or not, right? But now the fact that you are able to think about this kind of a solution, and we are trying to create an engineering solution for this kind of a problem, shows where we have progressed in the last couple of years itself, right? That's the speed at which technology is developing. I want you to keep that in mind, right? That is where the new kind of opportunities are in the market, right? Unlike the mean stack, the MERN stacks, which are vertical stacks, where all these technology stacks are staying on the same device. In an IoT system, the IoT stack is linear. The IoT stack is, the IoT stack is not linear. The IoT stack is actually distributed. It requires an embedded system to be built, which may have these C APIs that are integrated with these field networking devices over this, what I call was an IoT stack, using protocols like constrained application protocol over say UDP, or over or other UDP kind of messages over a CoAP, over a 6LoWPAN kind of an environment. It comes to the IoT gateway, from where we are seeing these these IoT systems are sitting outside of firewalls. So they are talking to the ML backend over an MQTT kind of an API, right, or HTTP long poles or WebSockets, right. Then you have the cloud systems, where there's a lot of third-party integrations. The simulators are being built, and the simulators are, again, they are running a machine learning algorithm in them, because the simulators need to generate a simulation which could be relevant to the kind of field data that you are getting in. Then you have the REST stack, you have the web servers and the mean stacks over here, which is building the IT system used in the control centers, used for the administration of the whole solution. And you have these mobile systems which are being used by end consumers, which can be used by the field engineers for commissioning the system, right, by the maintenance applications. So the IoT technology stack is not it's kind of distributed across different kinds of devices with different capabilities. That's the thought process I wanted to leave you with. What is the future of an IoT engineer? Well, IoT is growing faster than anything else. It's growing faster because IoT, it's not just the embedded and the communication piece itself. It's a lot of other things that are coming in part of what IoT is. You now need mobile apps for IoT systems. You now need web applications for IoT system. You are looking at cloud systems used in IoT. You're looking at machine learning algorithms for IoT. You are looking at essentially blockchain systems for IoT. So any new technology that is coming into the market is coming under this broad umbrella of IoT-based systems, right? And that's where you see the market growing, and new opportunities, new startups coming into the market. Because these are startups, because they are solving these new kinds of problems, these hyperlocal problems, or disconnected problems, if I can call them so. It gives you that first mover advantage, right? It allows you to go work for a startup which is building a new solution and have a shared risks, which means that you get better entry level compensation. There's inorganic growth and higher visibility within the organization, because you get to ride the hockey stick as the startup grows, right? There is opportunity for doing really, really disruptive work, completely new kind of work itself, right? It allows you to stay back with your electronics background, with your electrical background, no matter which area you're coming from. It allows you to build on top of that. And if you notice, it has not taken away from any of the current mainstream IT jobs, right? Those jobs are still there. It's just that you are now able to use those skills in a very, very different set of industries, right? You're able to use this not only, as I mentioned, right? You can, you don't have to look at just a coding job itself, right? IoT does not mean, or machine learning does not mean that you have to go into a coding job itself, right? There are other areas you can also explore, including field engineering. People who want to go and dabble into creating prototypes, you can look at R&D departments, right? You can look at academic research, product development, solution architectures, right? Product management. So there are multiple avenues that are also open, apart from pure play coding and development roles, right? Which are available in the market now, right? That you can aim for. And that brings us to a whole bunch of new kinds of companies which are recruiting in this space, right? I don't want to go into this into detail, because I want to take a few questions rather, right? But what you have to understand is, when these companies are recruiting, they are essentially expecting people with a some background in IoT based systems, with having an understanding that IoT systems encompass a lot of different kinds of devices, right? This picture that we had, this IoT tech stack that I had drawn out for you, they're expecting an understanding of that architecture, if you will, right? And that's where they are looking for people who have done projects on IoT, who have done maybe a particular use case, or have used the technology stack that is prevalent in the IoT based systems, right? And this allows them to kind of, if when you do projects like this, it allows you to go and defend the work that you have done in your interviews, right? Because the employer, you have to understand, is that the employer has their own dilemma. Without the provenance information of what kind of projects you have done, they are also concerned that if they hire somebody, they are going to come in and have the same productivity or the same retention as a lateral entry, right? So that's why they are looking for some amount of assurance based on the projects that you have done, right? So I will stop here. I'll stop here in terms of the presentation itself. For those of you who are unaware of what we do at Capsule Labs, we do offer a lot of certifications around various areas of IoT, but I am not going to go into that. Right? I will take questions instead. I think that would be a better use of our time. Yes, I'll open up the floor for questions then. I'll just put up an attendance link for today's. So I have a question which says that since I talked about Moore's law, there's a buzz that Moore's law has come to an end and no more adjustments can be done on chips. So we have been hearing this. We have been hearing the doomsday scenario on Moore's law for a very long time, and yet we have found ways to break that, and somehow things have kept on going. I mean, we now have almost a 5-nanometer technology that is going in the wafer space. The other thing that is happening is a lot of the systems are now being built on essentially more RISC architectures rather than CISC architectures. So the power consumption of these devices are falling significantly, which means that we are now able to build applications or build infrastructure, build more computation at the edge. So while the individual computation capability may drop, but the rate at which we are creating computation and the ability and the fact that all these devices are kind of interconnected means that we have a lot of computation available at our disposal to solve a particular problem. So that's how Moore's law is getting addressed in terms of our capability to handle computations. I mean, think of blockchain, think of all the mining that is happening. A lot of computers have come together to process things faster and faster. That's what's happening in the IoT world as well, right? Apart from that, the other development that is happening is for multi-dimensional problems which are getting too hard for conventional computers to solve. We are starting to see the emergence of new quantum computing algorithms as well, which are being tested on real hardware now. Unlike previous times where it was completely like Shor's algorithm and all, like, there's a lot of these new algorithms which are being computed almost on a near real-time basis for these systems. Sorry, my the attendance sheet was not accepting attendance earlier. I've fixed that. How is ML or IoT going to advance in the chip design in future? That is a very, very interesting question. Pretty much every company today is working on ML at the edge. So you have a lot of the, for example, a lot of the cell phone companies, or the MediaTeks, the Qualcomms, they have been looking at dedicating entire portions of their of the SoC surface area for AI related algorithms, including facial recognition, including camera optimization, including touchscreen fingerprint identification, right? A lot of these things. If you look at Nvidia, they are pushing a lot of AI on their right from their Jetson platform. There's a lot of neural network chipsets that are being made available with unprogrammed maybe 8K, 16K neural nets kind of inbuilt, right? So that's significantly improving the ability to set up and run deep neural networks on hardware itself, right? So there's a lot going on in that space. Gurdam asks if AWS IoT is dominating the IoT domain. I wouldn't say so. I think all of them are even players. If you are looking at a lot of natural language processing, IBM is doing really well. They have their context awareness, especially with they have been creating these bots with for playing Jeopardy, right? Which is a context aware game. You have to look at, when you are answering a question, you have to look at a lot of different aspects to be able to answer up one of those Jeopardy questions, and that is a significant step up from what was deep blue, or chess playing algorithms before that, right? Which were more mechanical, which were more robotic in nature. uh, Pardon me, I've fixed the attendance. I've fixed the attendance link. I'm accepting reports, attendance there. So for AWS, given that it has a large play in the IoT ecosystem, AWS has been introducing its own set of not only tools on the ML part, but it has also been working on something called AWS Greengrass, which is an embedded code that talks directly to the backend infrastructure. It's been developing something called, I think it was called Sidewalk, if I'm not mistaken, which is a low power, long range radio transmission capability. So AWS has its own ecosystem. Google has its own ecosystem, all the way from Firebase to its own set of uh, voice recognition software, conversational platforms. So it has its own ecosystem. Azure is very good when it comes to interconnections between, its what they call as a device twin, and the data that is residing on the end device. So it can asynchronously match up these two devices. It's got its own MQTT-like protocol called AMQP, which allows the end devices to communicate with the Microsoft IoT gateway, right? So all of them are good. All of them have their own pros and cons. All of them have their distinct advantages and disadvantages. So depending on the application that you are building and the kind of infrastructure that you are already, or the ecosystem you're already tied down to, you pick your provider. Yes, Anubhav. Yes, Anubhav, go ahead. Uh, Anubhav says, if you join a course on Capsule Labs, will you be able to show my experience to known companies? Means will it be recognized? We can discuss that offline, right? So typically, the certification that we offer is slightly different. Our focus, more than the certification, our focus is on essentially minimizing attrition in companies. What we try to do is look at why do people move out from these IoT companies, and primarily that happens because of a mismatch between somebody's skill set and the kind of work that the company gives them, right? So that's the problem that we try to address, and our certification looks a little bit different because let's see if I can show you that, because we don't believe in just the certification itself. We look at the process. We look at creating and changing the thought process itself, and emphasizing a lot on project execution, on project planning before its execution, right? The idea being that if you can de-risk a particular project, it allows you to deliver that project much more effectively, and it allows you to defend your project much better, right? uh, we have a recommendation engine that we are working on, so that whenever there are new jobs coming up, and when a recruiter kind of gives their requirements, they specify what they want in a particular candidate, the candidates are automatically ranked rather than going through a testing mechanism uh, to to uh, to find out who, to go through a whole list. It makes recommendations based on the kind of project that somebody has done, and tries to match them with the kind of opportunities in similar companies which are already doing a project which is in that area. And when we do projects, the goal is essentially comes from the candidates themselves. We let them pick what is of interest to them, and let them build skill sets that they are excited to work on, right? We can have the discussion offline about this as well, right? Uh, there are three price points in because you asked about price points. It is free to audit. You can go through the entire methodology for free. There are two particular architectures that we support at an entry level, because we feel that those can be solved within a 250 to 300 hours kind of an effort. And then there are more complex architectures which has more pieces into it, so the integration is a little bit more complex. We charge essentially for the support package rather than the course itself, and the support package essentially looks at, whenever you are stuck with something and you need either email support or counseling, that's where the charge comes from, right? Otherwise, going to the course is, you're free to audit. Gurram asks, what can we expect in Industry 5.0? I think Industry 5.0 has to be, it has to be carbon neutral, right? It has to be sensitive towards production. It should not be overproducing. We should be looking at a lot of SaaS services that has to be integrated into the production. And we have to look at a significant amount of recyclability of the product. So companies can no longer just make something and forget about it. They have to own the whole value chain of bringing it back into the system, ensuring that there is nothing that is left behind, right? That's where my vision of Industry 5.0 is. Right? I hope it answers. Any other questions that I can take? We are a little bit over schedules. Can I share the attendance link? Of course, I think so. There you go. I'll try to send out a certificate of participation for those of you who are attending today. I don't know if it is if it will be useful in your department, but if it is, all the best.
Thank you, sir. Now my friend Ajay will give vote of thanks.
Yeah, thank you, Puneet. And we feel really privileged to have Atanu sir here with us to grace this event with his presence. To receive such an immense amount of knowledge in the field of machine learning was an interesting experience. I'm sure all of the students were inspired after this event and will look at IoT as a new career opportunity. Special thanks to Atanu sir for conducting such an amazing event. Also, thanks to Team IoT and IEEE for making this event a success. Thanks a lot for joining this event and have a great evening. Thank you, sir.
Thank you, everybody. Have a good evening. Yes, please, you can contact me on WhatsApp.
Thank you, sir.
Yes, sir. Thank you.